Don't lose focus today. We finish on time so that you can have class time to start working on your reviews. Now, you should be into the session of one review. The review you got that you worked on whichever day you didn't go to guidance was just over circles, ellipse, and hyperbola. But don't fret. There's more. Okay? So I have a review. I actually have 2 reviews to cover everything. One's mandatory. One may end up being optional. We'll see how it goes. Okay. So we talked about parabolas. We know they can open up or down, left or right. That's right. That's left. Okay? So if it's x equals, this is the new part. Our geometric definition of a parabola was a set of all points in a plane that are equidistant from the fixed point called the focus and the directrix. So with a parabola, those are the things we need to know. Where the vertex is, what the focus is, where the directrix is. We also talked about, because it's a set of all points in a plane that are equidistant, if we define this as P, this is also P, so that distance is 2P. So if this distance is 2P, so is this one. Right?
Yeah.
And that's why we know to double P, because this distance also has to be equal to that distance. That's why we double P from the focus to get the 2 points on our graph. So when I am checking the graph over the spring break, yeah, that's when I'll be grading your papers. I'll be looking for the focus in the right spot, the directrix in the right spot, and 1, 2, 3 accurate points on your parabola. Okay? All right, so we all have this?
Yeah.
Fabulous. Let's move on. So, this was the back of those notes. Did we get to number 4 in this class?
No.
Okay, so we're going to pick back up with this so we can put our brains back in parabola mode. All right, so our vertex, the opposite of what's with our x is the x at the vertex. The opposite of what's with the y is the y at the vertex. So if they give us a form other than this, I like to write it in this form. All right, so the vertex can be found at the point 5, 1, 2, 3, 4, 5, 1. All right, what do we find after the vertex? Focus. Yes, we find the focus. And how do we find the focus? First, we have to solve for P. So, we take 1/4, set it equal to 1 over 4P. We can tell P is 1. Cross multiply, you get 4P equals 4, P is 1. Okay, so it's x equals, it's going to open right, so the focus has to be to the right. So the focus is the point 6, 1. Now, I double P to find the 2 points. So 1 doubled is 2. Go up 2, go down 2. Graph your parabola. Whoops, I went down 3. We can slide that right back up. There we go. Okay.
So we
just not
double
working.
P every time, right?
You double P, yes.
Okay.
Because when we double P, that creates our focal width. So now we have this side of our parabola and that side. And the distance right here across at the focus is 4P.
Okay.
Why did you go to the side instead of going up?
Because this is an x equals, so it has to open right. So I had to create it. And guys, I should have started with that. Every time we get one of these, it's probably best to go ahead and do a little sketch. This is x equals and positive, so we know it's going right. So the focus has to be inside. The focus is always inside. All right, now let's do the directrix. If we went P units this way, we go P units the other way to create the directrix. So it is the equation x equals, and that x value is 4. Okay? All right. Number 5. This is x equals and negative. Which way is it going? Up, down, left, right?
Left.
Left. So the focus has to be inside. The directrix has to be outside. So we know it's going to end up looking something like that. Where's the vertex?
3, -2.
3, -2 is correct. 3, -2 is the vertex. Okay, now we find P. Okay, so -1/12 equals 1 over 4P. P is -3. Very good. Okay, which tells me the focus is 3 units back.
Yes.
So the focus is the point 0, -2.
Why did that?
Okay, so this distance is 3, so we double that. Up 6,
Yeah.
down 6. And so we go off the graph a little bit. Oh, that's a terrible graph.
It's okay.
Thank you.
It's not,
Thank you.
it's fine.
All right, and then we go back 3 this way.
6, -2.
So that is x equals 6. Awesome. All right, this one. This is a y equals and this is negative. Will it open up, down, left, right? Down.
Bam.
Okay, so the focus has to be in here. So our vertex, the opposite of that is our y. The opposite of this is our x. So it's -1, 3. Now we solve for p. So we take this, -1/8. Set it equal to 1 over 4p. We get p is -2. Which tells me the focus is down 2 units. So down 2 units puts us at -1, 1. Now if I double that 2, 2, 4, 2, 4, I get these points. And then the focus would be up 2. We're going the other direction, so it's y equals 5. All right, how'd you do?
Okay.
Good.
Good. Awesome. Okay, so today we're still working with the parabola, and I'm just going to take some problems off the worksheet you guys picked up as you came in. If you didn't, they're still over there on the bookshelf. All right, so what we're going to be doing here is we're going to sketch what they give us and then find the equation of the parabola. All right, so I didn't put a blank for that, which is dumb. We should do the equation of the parabola first. And then the directrix, but I just didn't give a space for it. It's all right. So maybe we'll do this down here. All right, anytime I give you characteristics of a conic, I would sketch them, even if I don't give you a graph. Because sketching them helps us to see what it is. So this one has a vertex here, and it has a focus here. All right, so the focus always has to be inside the parabola. So this parabola has to open up, okay? So it has to look like that. So now we know it's going to start with y because it's going up. So it's y minus the y value at the vertex. Oh, y minus 0. We don't really need to write that. And then it's 1 over 4 times p. 1 over 4p. Well, what is p if these are 2 units apart? 2. And then x minus the x value at the vertex squared. So this equation, I didn't need to do that, is really just y equals 1/8 x squared. And that's my equation. Okay, now if I ask you to graph it, since we know this is 2, how far do I go out on either side? 4. And we could have that, and then since this is 2, we go down 2 in the opposite direction to get our directrix, which would be the equation y equals -2. You try number 2. Okay, that actually should say the vertex is at 0, 0. I don't even think it tells you that's the vertex. So if you assume that was a vertex, that's what I was looking for. So if the focus is right here, we know it's going to open left. So it's going to start with x. So it's x minus the x value at the vertex.
Negative.
1 over, and you're right, it is negative. Because p is negative 2, that makes this negative. And then y minus the y value. So the equation ends up being x equals negative 1/8 y squared. All right, if you were asked to graph it, you would double p. P is 2, so we double that, that's 4. And then our parabola should look a lot better than that, but it's opening correctly at least. And if p is 2, we go to this direction to get the equation of the directrix, because this is a vertical line, is x equals, and it's x equals 2. Okay? All right. Now, ooh, this one's good. Vertex, not at the origin. Give it a try.
Is this all we're learning?
And completing the square on the back. Okay, so the vertex is the point 2, 3.
Yep.
The focus is 2, 2.
Yep.
Okay, so if this is, the vertex is 2, 3 and the focus is 2, 2, it's got to be opening
Down.
down. Okay, so we're going to start with our y. Y minus the y value at the vertex.
3.
Okay, because it was down 1, I'm going to do 1 over 4 times negative 1. So that ends up being negative 1/4. Okay, and then it's x minus the x value at the vertex squared. So the equation is y minus 3 equals negative 1/8 x minus 2
4.
negative 1/4. Yep, you are correct. X minus 2 squared. Okay, so if this is 1, I go 2 and 2, and it graphs like that. And my directrix would be 1 up from that, so it would be the equation y equals 4. We get it? Cool. All right, what happens if they give us a focus and we look at it like this and we determine our p is a decimal or a fraction? You can think of it either way. Not really a big deal.
Just graph it.
Okay, so here's one. I didn't give you a graph. I would still sketch it. Okay, so I've got vertex at 1, 2, the focus at 1, 2.25. So I know it's opening up. Okay, so it's going to be y minus my y value equals 1 over 4 times 0.25. Because the distance between here and here is 0.25. That's where the p comes from. Okay? And then x minus my x squared. So it's really just y minus 2. 1 divided by 1 is just 1. So you don't have to write the 1 there. That could be your answer. Okay?
So how do you graph it?
How do you graph it?
Yeah.
Alright, I would graph this one the old way.
Oh.
If you remember the old way, we start with a vertex, and instead of doubling 0.25, which doesn't really help me that much, I can think of this as a squaring function. So if I moved one move to the right, 1 squared is 1. If I move 1 to the left, negative 1 squared is 1, and then that still gives me 3 points. And I can actually draw a better graph.
Were you asked about this in the past? Like graph it?
Probably I'll focus on the things we focused on in class.
Okay. Not the graph, right?
But you can see this on the SAT, so be ready. Okay.
Be ready, goes like
Actually, probably ACT. I take that back. I doubt they'll ask you about a focus and a directrix on the SAT. If you see either of those, it'll probably show up on the ACT. And I haven't seen very much of that at all looking at the review material. Anybody that's done the ACT seen that? You haven't seen it? Okay. I don't know that you'll see that there.
Nah.
Okay. This one gives us a focus and a directrix. We are missing the vertex. So we're going to sketch it. Well, in this case, we actually have a graph, so we don't even have to sketch. We can make a nice drawing. This is 2, negative 1. That's our focus. The directrix is x equals negative 2.
big direct.
All right. The vertex has to be halfway in between. By definition, the distance from the vertex to the directrix and the vertex to the focus is the same. So it has to be halfway.
0, negative 1.
0, negative 1. Yep. So the vertex is 0, negative 1. Which way is this one going to open? Up, down, left, right?
Right.
Right. Okay. This distance P is what?
2.
2. So I would double it, and I would go up 4 and down 4. And there's a graph. And then the equation would be x minus the x value, which is 0, equals 1 over 4 times p, which is 1/8, y minus the y value squared.
Plus 1.
Yeah. All right, number 9 is number 9 you actually could see on the SAT. If the vertex is here, it opens up and it passes through this point. So if the vertex is 0, 0 and it opens up, we know it's y equals something times x squared. They didn't give me the focus, they didn't give me the directrix. So that 1 over 4p doesn't really help me. That's helpful if I have the focus or directrix. So they gave me a point. I can find that coefficient by plugging in the point. So if I plug in the 16 and I plug in the 2, do you see I can solve for this? So I get 16 equals 4a, so 4 equals a. Now, this is definitely one that is best to use moves for. Because if I plug in 1, 1 squared is 1 times 4. If I plug in negative 1 squared is 1 times 4. Finding p is not helpful on that problem. When p is a tiny fraction, it doesn't make sense to use p to graph it. It just doesn't. So, if all else fails, once you have an equation, you can always just plug in x values to figure out what y is on the graph. No matter what graph I give you, even if it's something you have never, ever, ever seen, you can always plug in 1 for x and see what y is. Plug in negative 1 for x and see what y is. We can always test values. Okay, now, have 2 examples on completing the square to put a parabola in conic form. Now, how do we know? We have talked about this on every single conic. How do you know it's a parabola? Only one variable is squared. And tomorrow, I did type up the graphic organizer. I did. Everybody gets this tomorrow.
Whatever.
Oh.
Yes.
Or
Not for the test, but to study. Okay? And the first thing is, are there 1 or 2 squared terms? Because if there's only one, it can only be a parabola. Okay,
Can I get
so,
that tonight?
Yeah.
sure.
Since I'm eat.
All right, thanks, Moby.
Where are you going?
Okay, here we go.
Where are you going?
Now,
Taking my time.
we can tell the x is the one being squared. So when we're completing the square, the x needs to stay. Everything else has got to go to the other side. And when it moves to the other side, we change the sign. And now we have to complete the square for our x. But we've done this like 600 times at this point. So you take half and you square it. And you add that to both sides. Then you write it as a binomial squared. And we're done.
Oh wow, that's really simple.
But how do you know it's just one answer?
You only have to complete the square once with a parabola because there's only one squared variable.
So if there's two, like a quadratic equation.
If there's 2 squared,
yeah,
it's not a parabola.
Okay, so it's like maybe something else.
Yep, it's either an ellipse, hyperbola, or a circle.
Oh, this is just okay.
Okay? Now, this is also a parabola because only the y is being squared. So the y gets to stay. The other stuff has to move. I don't like the negative coming first. I'm going to change the order. I'm going to put the 2x first and then, I like that better. That looks more pleasing to the eye.
Agreed.
But all of these have like multiple terms at one time? Never mind.
What?
Never mind.
All right, so now we have to complete the square for the y. But this time it has a leading coefficient. And when it does, we have to factor it out. So this -8 turns into a -2. That's right. All right, so we take half, we square it.
No.
But to the other side, what do we add?
4.
4. Okay, so this becomes 4 times y minus 1 squared equals
2x plus 1.
2x plus 1.
Oh, that's all?
Now, no, that's not all. We have a slight problem.
We have to.
It is not,
Ooh.
we got a 2 right here.
Divide by 2.
We divide by 2. All right, but what happens is we got to divide this by 2. Can I just, and I have to divide that by 2 and that by 2. Yeah, and then I have it. 2 goes into 4 2 times. Those cancel, that doesn't. So I'm left with 2 times y minus 1 squared equals x plus a half. And I'm finally in the right form.
It's a party.
Do we need
Okay.
to draw this out? Like, draw this out? Drawing the graph?
I'm not going to make you draw the graph for that one. Okay? I just wanted you to have some practice completing the square. All right, the rest of that worksheet is tonight's homework.